Hello, and welcome back to Calendar Math with Mrs. Udoh. I am so happy that you are joining me today. During our calendar math session today, the littles will use hundreds charts to find numbers that are one more, one less, 10 more, and 10 less. Our middles will solve problems involving elapsed time, and our senior scholars will explore division using place value strategies. All right, guys, let's begin. Do you know what month it is? Remember, it's the fourth month of the year. Last month was March. Next month will be May. What month are we in now? You guessed it. It is the month of April. What day is it? It is the third work day of the week. And so when we're in school, we have now been in school for 3 days. What might today be? Do you know? Today is Wednesday. Well, if today is Wednesday, what was yesterday? If today is Wednesday, yesterday was Tuesday. Well, if yesterday was Tuesday and today is Wednesday, what will tomorrow be? You got it. Tomorrow will be Thursday. Yesterday was Tuesday. Today is Wednesday. And tomorrow will be Thursday. Let's take a look at our calendar. All right, guys. Remember, our calendar places a number with each day of the month. For the month of April, our month started on a Wednesday. Let's practice counting together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. If yesterday was day 21, what is today? What number is one more than 21? You got it. Today is day 22. We say that today is the 22nd. All right. So what is today? I'll start. Today is Wednesday, April 22nd, 2020. Remember, we start with the day of the week, then we say the month, the number, date, and then the year. You try. Today is Wednesday, April 22nd, 2020. Great job. All right, littles, it's your turn. Our number for the day is, can you guess? It's 22 because we are in the 22nd day of the month. Today, we are going to practice finding one more, one less, 10 more, and 10 less using a hundreds chart. Now, you may notice that my hundreds chart is a little short. We're just going to use half of it today. So we're going to call this a 50s chart. Now, when we want to find one more, one less, 10 more, or 10 less, We start by finding our number on our chart. Can you find the number 22 on our chart? There it is. Here is our number 22. Now, we are going to see if we can figure out what number is 1 less than 22. 1 less means that it is the number that comes before the number 22 on our hundreds chart. Can you find the number that is 1 less than 22? That's right, you found it. The number that is 1 less than 22 is 21. Great job. Now, let's see if we can find the number that is 1 more than 22. The number that is 1 more than 22 is a number that comes right after 22 on our hundreds chart. Can you find the number that is 1 more than 22? There it is. The number that is 1 more than 22 is 23. Do you notice anything that is similar or the same about our numbers? Let's take a look. 21, 22, 23. Did you notice that when we say those numbers, 21, 22, 23, all of our numbers started with 20 because they all have a 2 in the tens place. Also, did you notice that our ones place, each digit increases or goes up by 1? Let's take a look. 1, 2, 3. How cool is that? All right, guys, let's see if we can find the number that is 10 less than 22. Again, now we're looking for the number that is 10 less than 22. The number that is 10 less than 22 should be the row above 22 in your chart and should be right on top of it. Can you find the number that is 10 less than 22? There it is. You found it. The number that is 10 less than 22 is 12. Great job, guys. We've got one more. Well, if 12 is 10 less than 22, and we found it by looking right on top of our number, where do you think we're going to look for the number that is 10 more than 22? That's right. The number that is 10 more than 22 should be right below it. What number is 10 more than 22? You found it. The number that is 10 more than 22 is 32. Do you notice anything about our numbers in this column? I see that our numbers in the ones place are all 2s. That means they're exactly the same. If we look at our tens place, we have a 1, a 2, and a 3. Our numbers were 12, 22, and 32. When we were in the tens place, our number increased or went up by 10 each time. Great job, littles. All right, middles, it's your turn. Today, we are going to measure time in intervals in minutes. All right. And so remember, our number of the day was 22. And we are going to use this number in a word problem. Let's begin. Kayla is baking cookies. She puts them in the oven at 3:05 p.m. If the cookies bake for 22 minutes, what time will they be ready? We are going to use the idea of a number line to help us find the answer to this problem. And so we are going to be looking at time in what we call intervals, which just means small pieces. So let's start our line with the time that she puts the cookies in the oven. Kayla puts the cookies in the oven at 3:05. We know the cookies are going to bake for 22 minutes, but we want to find a strategy that is going to help us to figure out what time that is. The first thing I want you to think about is whether or not the time is going to be before 3:05 or after 3:05. Are we looking for a time that is earlier or a time that is later? You got it. We're looking for a time that is later than 3:05 because the cookies need time to bake. So to help me figure out the answer to this problem, I am going to break my 22 minutes into pieces that make it easy for me to add on so that I can get to the time that I'm looking for. So from 3:05, I'm going to leap forward in time. And when I think about a number that's easy for me to add, the first number that comes to my mind is 10. And so from 3:05 p.m., I am going to add 10 minutes because remember, we're talking about a time that occurs in the future. So if I add 10 minutes to 3:05, the time is now 3:15 p.m. So at this point, I have moved 10 minutes into the future. But how many minutes do I want to move? That's right. I want to move 22 minutes into the future. So from 3:15, what interval might I use to move forward in the future again? You got it. I'm going to move 10 more minutes. Now, if you wanted to move 5 minutes, you could definitely do that too. So let's hop 10 minutes into the future. All right, we've now moved 10 more minutes into the future. And if the time was 3:15 and we move 10 minutes into the future, what time is it now? You got it. The time is now 3:25. So at this point, how many minutes into the future have we moved? We have 10 and 10. So we've moved a total of 20 minutes into the future. But how many minutes does it take the cookies to bake? That's right. It takes 22 minutes to bake the cookies. So how many more minutes do I need to move forward? That's right. I need to move forward an additional 2 minutes. So from 3:25, if I move forward 2 minutes, what time will it be? You guessed it. The time is now 3:27 p.m. So if Kayla puts her cookies in at 3:05 p.m. and they bake for 22 minutes, Kayla's cookies will be ready at 3:27 p.m. Great job, guys. Let's take a look at one more. We're going to use that same number 22. This time, We have Ryan. And Ryan went to his best friend's house to play video games. He arrived at 12:14 p.m. If Ryan if Ryan lives 22 minutes away, what time did he leave his home? So Ryan goes to his best friend's house to play video games. He arrives at his friend's house at 12:14 p.m. If he lives 22 minutes away, what time did he leave home? This problem's a little bit different. Can you tell me why? Exactly. In this problem, we're trying to figure out what time Ryan left. And so it's time that happened in the past. So instead of our time pushing forward, we're now going to have our time push back. And so instead of starting on the left side of my number line, I'm going to start on the right. And we're still going to start with the time that they provide us, which was what? 12:14, exactly. So 12:14, Ryan is at his friend's house. And we're trying to figure out what time he left home. We can use the exact same process using our intervals. So if I come up with a number for a time in the past, I can get closer to when Ryan left his house. What number would you like to use first? I like 10 as well. So this time we're going to go back 10 minutes. Here we go. So I'm going back now 10 minutes in time. And if it's 12:14 and I go back 10 minutes, what time is it now? Well, 14 take away 10 would give me 4. And so now the time is 12:04 p.m. So at this point, I've gone back 10 minutes in time. And so I still have 12 minutes in time I need to go back. Now, here's where it gets a little tricky. Because when we're looking at time, when we get to the hour, we know that we transition from 60 or the 00 down to 59. And so how can I make this a more smooth transition? What interval would you go back? I think that the interval that I would use to go back is 4. Do you know why I went back 4 minutes? That's right, because going back 4 minutes puts me at 12 o'clock. So if I had 12 more minutes to go back and I went back 4, how many more minutes do I need to go back in time? You got it. 12 minus 4 equals 8. Absolutely. So if the time is 12 o'clock p.m. and I still need to go back 8 minutes, what time will it be? Again, keep in mind, the 00 is like a 60. And so if I have 60 and I subtract 8, what number will I be at? When I subtract my last 8 minutes from 12 o'clock, it puts me at 11:52 a.m. Did you notice that my time changed from p.m. to a.m.? Why is that? That's right, because 12 o'clock is noon. That is the middle of the day. And so once we go down past noon, we are back at the morning. So we know now that Ryan left home at 11:52 a.m. in order to get to his friend's house by 12:14 p.m. Great job, guys. All right, time for my scholars. Let's do it. For our problem today, we are going to use place value strategies to divide whole numbers. Our number of the day is 422. 4 for April, and then 22 for the day. Our division problem for today is 422 divided by 4. We are going to start by using a strategy for our base 10 blocks. And so we are going to go completely concrete to start. So the first thing we're going to do is we're going to model 422 with our base 10 blocks. What do you think 422 looks like with base 10 blocks? Did you get this? Did you say 4 flats? So 100, 200, 300, 400. 2 rods, 10, 20, and then 2 units, 1, 2, 422. All right. And so when we're talking about division, what does it mean to divide? Exactly. Dividing means splitting into equal groups. So we're going to take our base 10 blocks and we're going to split them into equal groups. How many equal groups are we splitting them into? There you go. We're splitting them into 4 equal groups. And that is this 4 right here that we know that by. So here we go. Here are my 4 groups. Typically, when we are dividing and we're splitting into groups, we can start with our biggest unit. And so for us, it's our hundreds. And so we are going to take 100 flat and we're going to place it in each box. And again, we want to make equal groups, so we want to make sure they're evenly distributed. So let's start that process now. So I'll move one here, and I'm going to mark it out to make sure I remember that I've used it. Here, here, here. All right. So at this point, how much of 422 have we distributed? That's right. We've distributed 100, 200, 300, 400. What is it that you think we would do next? That's right. Now we need to distribute our tens rods. Do you notice something about the tens rods? There's only 2 of them. And so if there are only 2 of them, we cannot take each 10 rod and put it in its own box. So what is it that you think we should do with them? We are going to break our tens into ones so that they can be distributed. All right, let's see what that looks like. So here's our first 10 rod. So we now have 10 units in place of that 10 rod. And then we break the other one. And we're going to mark through them to show that we're now using them over here. All right, guys. So once we've done that, we can distribute just like we did before. Let's go. All right, we've placed 1 in each group. Mark them out. Another, let's mark them out. Remember, we're focused on making equal groups, so we're sharing. All right, have we finished? Why haven't we finished? That's right, we still have those 2 units from our original problem. Is it at all possible to take these 2 units and distribute them into my 4 groups? Now I hear you thinking, Maybe if I split them in half, I could put half in each group. And that is actually a really great answer, but we're not going to get into decimals right now. For the purpose of our problem, because there are not enough of our units to go around, they become what we call our remainder. And so when we solve our problem or we provide our answer, we are going to provide our answer based on the number of pieces we had in each group. So each group has a hundreds flat and 1, 2, 3, 4, 5 units, meaning that 422 divided by 4 equals 105, and we can't forget our remainder 2. I know that was a lot of work, right? All right, parents, I know what you're thinking. This looks a whole lot more like it. Well, not quite. We aren't going to use the standard algorithm. We're still going to use a strategy based on place value. For this problem, we are going to use a strategy called partial quotients. And what that means is that our quotient or our solution is going to come to us in parts, and we're going to put the parts together in order to create the whole. And so in order to start, we are going to begin by looking at our divisor and trying to figure out what factor we can multiply by our divisor in order to get as close as possible to the dividend that we see here. So what number times 4 will get me close to 422? Now we don't have to get super close. We want to get as close as we can with mental math. And so what's the first thing that comes to your mind? The first thing that comes to my mind is by multiplying by 100. So 100 times 4 gives me 400. And so I'm now going to subtract 400 from my dividend. So 422 minus 400 gives me 22. I'm going to leave 100 up in my quotient because it's going to become a part of my solution. I'm going to take this 22 that I have left over in my dividend, and I'm going to slide it over because I'm going to use it again, following the exact same method. So again, our divisor is 4, and I'm looking for a factor that I can multiply by my divisor to get as close to 22 as possible. 4 times what gives me something close to 22? That's right, 4 times 5. 4 times 5 is 20. So if I subtract 22 minus 20, I still have 2 left over in my dividend. Can we follow the same steps again? Well, let's think about it. If I have 2 left in my dividend and my process has been what of my divisor times a factor is going to give me a dividend, is there a number that I can multiply by 4 in order to get close to 2? You're right, not a whole number. And so that means that this 2 is going to become my remainder. Now remember, when we began this problem, I told you that it was based on what's called partial quotients. Parts meaning they can be put together. So we're going to take our 100 and we're going to take our 5 and we're going to put them together. So 100 plus 5 equals 105. And then finally, we're going to pull up our remainder. Our remainder is 2. So 422 divided by 4 equals 105, remainder 2, which is the exact same answer that we got when we used our base 10 blocks. All right, guys, thank you so much for tuning in today to Calendar Math with Miss Udoh. I'll see you tomorrow.